So another project I'm looking forward to on the Model 4 is this delivery from Bartlett Labs. Let's go ahead and see if we can get the box open and take a peek at the goodies inside. Assuming I can get the tape here to cut. I always struggle with how to open these boxes. This still seems to be the best way, is to break the tape. If I can get it to cut here. Of course, I don't have a knife here with me, which would have made this far simpler. Let's see if we can get this peel open. Boy, is that sealed well. Got to be a better way to open these boxes. I just don't know what it is. Wow, that is really glued on there. Well, I have to say, U.S. Post Office, your adhesive works well. There it is. So we'll take a look at what we've got. We've got a nice long ribbon cable to go from the Model 4 expansion interface. We've got a boot floppy for the M3SE. This is the Model 3 system expander, which will work on the Model 4. So we've got this nice floppy with software on it. This is actually, I believe it's a bootable floppy. I've not tried booting the system off floppy yet. We've got a BOM here, bill of materials, with the parts, because I went ahead and ordered the kit version of this rather than the fully assembled, just because I enjoy putting kits together. We'll take a look in the bag at the parts that it came with. Assuming I can get the bag open. As you've seen, I'm not having great luck today opening things. I have been outwitted by glue again. So of course the little power brick to power it. Bag full of components, resistors, capacitors, probably a voltage regulator, I'm not sure. The various through-hole parts. The IDE 4GB compact flash that's got the LDOS bootable images on it. Looking forward to assembling this. I always enjoy assembling kits. There is a ROM here which replaces one of the ROMs in the Model 4, I believe, that allows it to auto boot to the hard drive emulation. There is the, I believe it's an FPGA array that actually the implementation is on. It plugs down onto the card. This is the network interface. And of course the blank board to be assembled. And you know, it's just a pretty straightforward soldering project. A few components, DC power jack, VGA connector, the joystick connector, the pins that go into the various boards that snap down in. So this should be a fun little project to solder up and get working and take my Model 4 really to the next level. Well, I've got the floppy here in my hand that came with the system expander. I'm going to assume it's a bootable floppy, though I don't honestly know that. Well, by golly, it is a bootable floppy. So we can see that this machine will actually boot from floppy. This is the first time I've attempted to boot the machine from floppy disk. It is 10/27/2017, I believe. Well, obviously not, because it thinks it's Tuesday and it's Saturday. Well, this is very nice. Very nice confirmation that the floppy drive is at least bootable in the machine and readable. It's like a pretty, looks like LDOS on here. MS3E init command, readme. Nice. That makes me very happy. So there's no readme program on here. Is it cat readme to type the file? Again, I'm jumping back and forth between OSs and always get kind of lost. Cat or type? Basic help, format help, fed DOS, there's various help files. Come on, brain, you know how to do this stuff. Setup. Well. Oh boy. I have so much to learn about LDOS. Anyhow, I'm very pleased to see that that floppy actually was bootable and the system will boot from it. I need to dig for a couple of blank floppies here and make a backup of this, assuming backup is on here. And it is. Very nice. Very nice. Well, while we're playing here, I will look for the couple of loose floppies I had laying around. And of course, in the mess I call my organized workspace. You never really know where anything is. That's the power of organization, because you can't find anything. There's a couple of blank floppies. So let's go ahead and see if we can back up the floppy that Peter supplied in the kit. Well, it would help if I could type backup correctly. And let's just reboot it. Backup. I'm so pleased to see this machine boot. Source drive is 0, destination drive is 1. I believe it'll detect it's not formatted or under a different format and ask to format it, though again I could be wrong. Or it could just hang up. Maybe I need to format it first. Insert destination disk. Enter. That kind of implies that the #1 drive is having issues. Double density, two-sided, 40 track. Yeah, there might be an issue with this second floppy drive. Oh, okay. There it's taken off. Hopefully you find it as entertaining as I do, how I head down one project path and it turns into a whole different adventure. From getting to assemble this kit, we'll assemble it together in video and test it. I do really enjoy kit assembly. I miss Heathkit. They made some fun projects. I'm sure the bomb here has all of the part values to match up to the silkscreen on the board. So, you know, box header, heat sink, resistor 3.6k ohm in R1, resistor 5.6k in R2, etc. So anybody with a little bit of experience assembling kits and who can use a soldering pencil and solder well should be able to put this together. It doesn't look that challenging. Pretty excited to see what I can do with this. I can say that I've come to really appreciate using this Model 4. As much as I love my Model 1s, it's just a much nicer system. Seems more reliable. I just think it's easier to use. I love the green phosphor in the CRT. I've always preferred the green phosphor. Backup. I don't remember if backup will create a bootable floppy or not. Well, I'm pleased. The floppy is formatted, and it seems to be source disks are right protected. Can't clear mod flags. Okay, yeah, that's fine. I just want to get the files transferred. So Model 3 System Expander init/command. The kit version of this is cheaper. Peter did say, though, in some ways it's as much work or more work, because of course he's got to inventory all the parts and make sure everything in the bag is everything I need versus just grabbing from his stock as he stuffs a board. He's still got to program up the FPGA. He's got to supply the gate array EEPROM, although we probably have to supply it the other way around. But you've probably seen my previous videos on the Model 1 System Expander and the Model 1 replacement expansion interface, and just very high quality products. Very pleased with what Peter has supplied. His engineering is rock solid. The PC boards look great. Just very pleased with what he's done here. You know, it's a commercial product. It's just, you know, it's a limited audience to us TRS-80 fanboys. Interesting enough, there is a surface mount device on the bottom of the board here. IC3. Not that I can't solder that up. I'm old school enough that through hole is really much more. IC3 is an AT24 MAC 402 8-bit SOIC package. So I'll get to do a little bit of surface mount. Not a problem. You know, I negative cap, yeah, so now there's actually a note on the negative lead of electrolytics, the direction, so it may not be indicated on the PCB, although maybe not, so I have to follow the instructions. Yeah, C5 here, I can see the plus sign. This guy down here, it's not as clear. I don't have my close-up vision glasses on, but nice looking board. I can't wait to get this thing up and running. Let's see what we can make the Model 4 do. I'm looking forward to getting 128K of RAM in it as well, and running a little memory test and see that it's there, and boot CPM and have a play on this thing as well. So anyhow, I'll wrap this piece of this up. You can see that it's copying. So my floppy drives do seem to be good. I'm pleased. For a garage or a barn find and a machine that was incredibly dirty, I'm very pleased how easy this was to clean up and how clean it was inside. So anyhow, I'll be back with an assembly video and we'll go from there. So I thought I'd jump into the Model 3 System Expander build. All the parts back here on the bench. We've got the two cards that get plugged in, the SD card case, the compact flash adapter, the little bag of loose parts, which I will get captured in something here so I don't lose parts. Of course, the main PCB. I like the fact that Peter uses this blue painter's tape because it doesn't leave any residue behind when you peel it off, as other tapes do. So we're down to the blank board. I'm just going to take a quick look at it close up. Let me find the right glasses and just make sure I don't see anything gross that stands out. And the board quality looks excellent. It's not a real dense board. There's plenty of clearance. It's a nice solid design. Yeah, I don't see anything, you know, that jumps out as a trace etch through or a short between pads or anything like that. I wouldn't expect it, but it's always a good idea just to take a quick look. I've got my JBC soldering station fired up. As you can probably see, the bench is rather a mess, as it usually is. Get some of the smaller parts here contained so they don't get pushed off the turntable and lost. I'm of course using a high quality multi-core solder. I think it's Kester brand. Always recommend multi-core. Multi-core relies to the flux that's used inside. The flux is part of the soldering process, and then it cleans the metals as they're being soldered. So suggested soldering order, the battery socket first. So the silkscreen layout gives me the orientation of the battery socket. If I can get both pins in the hole at the same time. We will solder up the battery socket. The lead here on the pencil has gotten rather twisted up. Applying a bit of downward pressure through the board just to make sure the battery socket is solidly in place. Battery socket is flush. The solder joints look good. It's the proper orientation according to the silkscreen. I will check that off. The IC1 socket must be that 14-pin dip socket. I know what's in the little box here because I remember specifically picking it up and dropping it in here. Although apparently my memory is faulty because I don't, there it is. See, I don't see it. And of course wadded up the blue painter's tape. I should have kept a piece of it to help hold components in place. You've seen me do this before if you've been kind of watching assembly videos on the channel. Make sure the notch in the socket is oriented with the notch in the silkscreen, which it is. Notch to notch, the pins are lined up, just tack it in place a bit. All 8 of the pins are through the holes. I will at this point reheat the 2 corner solder joints I did and just make sure the socket's pushed in flush to the board, and that side actually was a little bit high, so we can now solder up the other 6 pins. I'll retouch up that joint. That one didn't actually want to take solder. Clean the tip, and we have the battery socket and the 8-pin dip IC socket. He recommends C7, then C3. So C7 and C4 are 0.1 microfarad, 2.5 millimeter spacing. So let me do a bit of sorting here. Find a pair of needle nose that are sufficiently fine to reach down in there and grab parts. it's most likely that guy and that guy. These again were, see, C7 is a 0.1 microfarad, 2.55 pitch. I don't see any electrolytics or other ceramic caps floating around in here. I'm sure if I can read one of these, it'll be labeled 104. And it is. 104 is a 0.1 microfarad. They both are labeled 104. Doesn't seem too many capacitors around the crystal. There might be, you know, sometimes with the crystal there'll be a couple of 10 picofarad, or except for caps, we don't have that. So C7 is this guy right here. Flare the leads enough to hold him in there square. Hopefully this is on camera. It barely is, but it is. A pair of flush cutters. These flush cutters are getting rather dull. C7 is in place. I will mark him off. C3, C4 and 7, C1 through 3 are 10 microfarad electrolytic. Quite probably this guy. Yeah, 10 microfarad. There should be 3 of these for the bomb, which I'm guessing are these 3 devices. I would expect the physical size to be the same. The little watch crystal here that's used for the real-time clock has got a piece of tape around because it's so tiny it would be very easy to lose. You just recheck these to make sure they say 10 microfarad. It does. It does, and yes, 10 microfarad. So he wanted C3 next. Find C3 on the board. C1, C2, C5, C3. And there is a labeled plus on there. The long lead is the positive, the negative lead is the shorter one. There's a note here that says, someplace, where did I see that? Negative lead of all electrolytic capacitors toward CON1 edge of board. So there's CON1. I have the negative lead in that direction. And we will solder him up. Of course, you want to be applying heat to the pad and the lead both. Which is why you know, an appropriately sized tip helps, that you can get in there and make sure it's making contact. So there's C3, the negative end, which has got the white marking here, is towards CON1. There's C3. He specifies Jack 1 next is the DB9 for the joystick, which is this guy right here. There are 15 or 9 pins plus the 2 strain relief mounting posts that come through that are a little bit sprung. I'd like to get a little screwdriver in there and expand those slightly just to pull it up snugger, although I'm not seeing a small screwdriver at the moment to do that with. It's funny how you never have the tool you're looking for, even when you know it's here. Absolutely amazing that that little screwdriver that I used just a few minutes ago in a different video is now not here. Well, we will tack a couple of pins and then manually pressing flush. And then complete the soldering. You can see it's flush against the board. We'll walk through the 9 pins. I typically stuff boards the shortest components to the tallest, but in this case I'm going to go ahead and follow Peter's suggested build order. No reason not to. I've got a solder joint or two that I don't like the looks of. They're a little gray, not nice and shiny. Actually not enough heat. And I'm going to go ahead and solder the large tabs here. I happen to know that my JBC pencil actually has enough thermal capacity to deal with this and deal with it pretty well. And again, this JBC is a very high thermal capacity soldering station. Using other tools, your luck being able to do this as quickly and easily as I'm doing it will vary. So we've got the 2 strain reliefs through the large pads and then the 9 pins of the DB9 connector soldered in. So that's J1. He's got resistor 1, 2, and 3 next. There's a 3.6, 5.6, and a 10K. Hopefully I can fish all 3 of those out of here. The 10K is easy. It'll be black, brown, red. Well, I say that, and I'm looking at the markings, and that looks like 20. This is going to be a 3. This has got to be the 3.6K. I'm actually going to use the ohm meter to confirm these. They've got 5 bands on them, and I hate to say it, that always kind of confuses me. That looks like, I don't know. I'm going to just double check with the ohm meter. Just because it's safe to do. And switch to ohms. This guy is 10K, 9.98K, but definitely close enough. So the 10K ohm is at position R3. So they're all grouped right here together. In this case, I'm just going to use a finger bend to get it the appropriate size. And in flush. So 10K was R3. This is 3.59K, so it's going to be the 3.6K, and that's R1. And R1 is in the center here. I'd like to get the orientation of these the same, so I'm going to spin him around. Not that anybody ever notices except me, but it does make for a little bit neater installation. And this should be the 5.6K. And it's 5.59K. So yes, this is the 5.6K. And just to double check, that's R2. R2. And orientation will be this way to be consistent. Again, I will flare the leads. This is a better pair of flush cutters. The other ones have gotten dull. Yeah, this is much better. So I can check off R1, 2, and 3. He calls out J3. J3 is the jack for the barrel plug power. So this would be J3 right here. The best way I've found with these is to get it tacked in place with one pin, and then again finger pressure with reflowing the solder just to make sure it's flush, and then complete the soldering job. Let that sit long enough to cool, and I can see that it's crooked. Reflowed, it's now flush. I will solder up the other two pins, then I'll come back and reflow the original pin there. And again, high capacity pencil makes this pretty quick to do. I'll just add a bit of fresh solder and reflow him. And we've got Jack 3 installed. The next is C3, which is another 10 microfarad electrolytic. C3 is sitting, there's C5, C2, C1. Oh, I've already got C3 in. Did I do this in the wrong order? I think this is actually a typo on the page. C1, 2, and 3 are 10 microfarad electrolytics. That's C1, 2, and 3. So the negative lead towards con 1. The dull flush cutters out of the way. And I'm just going to go ahead and install the other 10 microfarad while I'm here at C1, 2, and 3. So there's C1, or C3, C2, and C1's over here. And again, the long lead, the negative lead. Oh, saying that backwards, aren't I? The long lead, the positive lead, towards the top of the board the way I'm holding it, and the negative lead towards J1. Set him in place as well, flare the leads a bit. And that gets C3 and C1. Let's just move on to C6. C6 is a 10 microfarad MLCC 5mm spacing. Where is C6? Get an idea of the footprint. .47 microfarad. That's the surface mount part. It's going to be this little guy potentially right here. C6, 10 microfarad MLCC 5mm spacing. Wish I could see that better, because that seems awfully small for 10 microfarad. Well, it's labeled 106, so 104 is 0.1, 105 would be 1, 106 would be 10. So what is this guy? It's a non-polarized device. Sits in right here. Oops. That takes care of C6. Jack 2 is the 15-pin high-density VGA connector, which is this guy. Same as the DB9 one, only it's got 15 pins. I'll catch a couple of pins, make sure it's flush, and finish the soldering on it. It looks flush, but I'll reheat those and just apply a bit of pressure. And we're fine. So now it's just a matter of walking the pins, being careful not to create solder bridges. These pins are a little close together. This is the, I think I said it a minute ago, the VGA port. The VGA is really a nice feature of this, to be able to drive a VGA monitor and not have to have your, like on your Model 1, the Model 1 monitor powered up. Of course, on a Model 3, the screen's rather built in, but I guess if you had a failed CRT, you'd still be able to use the computer. You could make a, an interesting second screen, although I believe it's mapped. Well, I don't know. I'm not sure how he's got this set up. I'm assuming it's mapped to the same address space as the TRS-80 video memory, but maybe there's some second magic. It'll turn this into a second monitor. I have no idea. I've not looked close at the design. So that's touched up. We will get the strain relief here. So that flows around the backside and fills in. So we've got all 15 pins, and we've got the 2 strain reliefs, so that's happy. Resistor network 1 is a 3.6K. Looks like I'm seeing 4, I believe, resistor networks here. And that looks like a probably 470 ohm. Yep. 470 ohm. There must be 2 of those. Resistor network 4 and 5 are both 470 ohm. That is a 750 ohm. It looks like a 75 ohm. There's one of them. And there's one, and there must be, there he is, a second. Which one did he call for? Resistor network 1 is the 75 ohm. It should be this guy. As always, I will confirm. Resistor network, you can just go end to end. Typically, well, this may not be a bust. It may be a, yeah, 75. So this is going to be, okay. It's not a bust. It is a, it's 4 individual resistors inside of the package. So 75 ohm, 8-pin or 6-pin dip, resistor network 1. In this case, it is an 8-pin dip. In this case, because it's not a non-bus type orientation, it isn't critical. See if I can flare these 2 outer leads a bit, just to kind of hold him in place. Resistor networks, I like to tack 1 pin down and then get it nice and straight in the socket so it's standing up nice and straight. Then finish soldering that. I just think it makes a nicer looking install, and actually that was really close. So that was resistor network 1. It moves on to resistor network 4, which is an isolated times 3. We said these were 470s. So again, this is a non-bust. It's just 3 470 ohm resistors in a package. Again, it is what I expect it to be, and that is going to go in position resistor network 4, which is right here next to the one we just put in. See if I can flare the leads a bit, just to keep him from falling out. I touch one, and I'm going to see I'm going to have to manually flush this up. And he looks nice and straight as compared to the one next to it. So we will finish soldering him up. That was resistor network 4. Q2, 3, and 4, I'm sure, are the 3 transistors. Oh, interesting. Q2 through 4, 2, 3, 4. So what is Q4? Q4. I don't see a Q4 on the list. What's the silk screen? Q1, Q2, Q3. I believe that may be another typo. I'm sure he meant Q1, 2, and 3. Well, it happens. I'm not sure how many kits he's sold of this, and I'm not sure how many people tear over details like I do. It's one of the reasons I write documentation, is I have a pretty good eye for this kind of stuff. There's only 3 small transistors in there, and it's a 3904, a 3904, yep, and a 3904. So these are the correct three. Work these into place. I want them all at the same height. We're very close to it. Spacing even, again, it's just a neatness thing, but I am a firm believer that, of course, you look at my bench and you think I'm full of it, that neatness counts. When I'm assembling a board, I do like to get things nice and clean and tidy on the board. Bench is a different story. The bench changes hour to hour as I'm doing work. Or once the board's assembled, it's assembled. Those look good. I'm going to clip out the emitter and collector pins first, and then I'll come back around and solder up the base pins, as removing these pins will provide clearance. I'm going to have to switch glasses here. Eyes are starting to fatigue a bit. And I don't have the ones on I should have started with, it turns out. So that's the 3 transistors. Let me find the glasses I should be wearing, which are these. Resistor network 5. Resistor network 5 is a 470 ohm isolated, which is this guy right here is the other 470 isolated. And I believe this is the last resistor pack for the video section. I will again flare the pins, a couple of them just to hold it in place. Straight at that end up, that looks good. So that is resistor network 5. There's still 2 other resistor networks, but he calls out Con 2 next. So connector 2 is this guy. He's got notes here someplace for the orientation. I swear I read someplace. Con 2. For CF adapter, notch towards R2. So he's referring to the notch in the housing here, and he wants the notch towards R2. And that way, the CF board will go in the correct orientation. Can only go in the correct orientation. I'm going to put a little piece of tape on that. And again, I'm just going to touch a couple of corner pins I'll come back and manually make sure it's flush before I solder the rest of the pins. And anything that's polarized, you need to make sure the orientation is right. On a connector this big, if you got it in the wrong way around, you'd either be, ow, burnt myself, you'd either be cutting your own notch on the other side or destroying the PCB trying to remove it and turn it around. Neither one of which would be fun alternatives. So let's walk all these pins, all 40 of them. These will be fun. They're in what I'm guessing is a ground plane. There's a lot of copper around them to wick the heat away. And of course, advise you to be using a fume extractor, but as you can tell, I don't have mine on the bench today. Make sure this is in focus here. I had a pop-up on the camera saying it's in low battery mode, so I'm not sure how much battery life I have for shooting here. I will finish this row, charge the battery, and take a break. And hopefully we didn't lose a lot of my running monologue there with the pop-up on the camera. There's all 40 pins on the CF connector. The notch is towards R2. The solder joints look nice. Well, I'm going to pause at this point, take a break, charge a battery. So I've let the battery on the camera charge up a bit. We'll continue on here. Connector 2 is box header 2x20 pin, which is going to be, I'm sure, there's 3, 4, 5, 6, 7, 8, J4, switch 1, let's see, Con 2, well, let's just jump on to resistor network 2 and 3. Resistor network 2 and 3, one is a 10K, which is that one, and the other one is those are both 10K. Oh, 2 and 3 are both 10K, I misread that. So we have two 10K resistor networks. And these are busts, so you need to worry about pin orientation. So one is there, and I've got pin 1 to pin 1. Looks like this is probably a pull-up network, and we've got one more. Once I spot it, there's one there. Where's the other resistor network? 10K bust, R2 and 3, 10K bust, 5-pin SIP. We have one there. Oh, right there, right next to it. I'm just blind. It was right there in plain sight. Kind of flare these end pins out a bit to keep it from falling through. Cables out of the way. 1 pin on each one. And get it in flush and straight. Those both look good. Almost thought I had a solder bridge there for a second. So that takes care of those two resistor networks. Connector 2, con 2, box header 2x20 pin. There's a bunch of these headers, which are going to be these. There's 6 of them. Receptacle 2x14 pin. Con 3 to 8, 3, 4, 5, 6, 7, 8. Con 1. Oh, I've already got Con 2 installed. That's the confusion. Okay, I just didn't check it off the list. We have Con 1. In this case, the silkscreen has the notch in the silkscreen, so we know the orientation to put this on. I will tack a couple of pins and then push it back flush. And I can tell by the way that moved when I reheated the solder that it wasn't flush. Ooh, I just burned myself. Does happen. And we walk down the sea of pins. In this case, there's 50 of them, 25 signal and 25 ground pins. This, of course, comes in off the Model 3 or Model 4 expansion bus. I'm not sure how entertaining it is watching me sitting here solder. But we are making progress. We are going to get to that surface mount device here at some point, and that'll be a little bit interesting. Okay, the back row of pins are all grounds. They're all on a common copper pour there, which is a little bit beefier, so it'll take a little more heat to get good solder connections in all these. This basically takes every other wire in the 50-pin cable and grounds it. That helps with signal integrity and crosstalk and all those wonderful things that happen in cables. So even though there's a sea of them, it's worth getting a good solder joint on every one. Well, we're moving forward here. So that gets, I believe that was Con 1. C2, 10 microfarad electrolytic is already in place. We've got one more of these 0.1 microfarad. So there was 0.1, C4, and C7. We've got C7 in place. C4 is over here by that surface mount device, so I will hold off on it. Con 3 and 4, Con 5 and 6. So really we are getting down to these devices, and I'm not going to sit here on camera and take you through soldering all of these. I don't think that's necessary. It's just going to be a matter of getting clean alignment. He wants me to put on the anti-static wristband before continuing, which I can certainly oblige with. I've got my anti-static wristband right here. It's connected to the ESD map. It's underneath the turntable. So I am grounded. IC2 plus heatsink. IC2 is the 3.3 volt voltage regulator, which will be this guy right here. Yep, V33. His little heatsink, and we'll go through my belief on the proper way to mount something like this. So I kind of measure where to bend the pins, and it looks like to me to bend the pins is right where the wide part becomes narrow on the 3 pins. So I'm going to take and line these little pliers up, and I'm going to bend those to a nice 90-degree angle. It should sit in there. We've got good clearance through the screw hole. We'll take the little heatsink and screw. I need to get the heatsink down in there. And of course, the voltage regulator fell out, and then the heatsink fell off, but such is the nature of the beast. I tend to like to put the bolt up just because it keeps the bottom of the board flusher. I think that's probably one of those preference things. I'm sure people could argue it either way. The heatsink is pretty square. It's not quite. Yeah. Get a little more. I could have probably put some heatsink compound on that. I didn't. I suspect this isn't going to get this hot. I mount it first, and that way the pins are floating in here, and then I solder it, and that way I'm not moving the device up or down to get the screw hole to mount up and putting stress on the solder joints. So mount first, solder last. If I can pick up the solder here, we'll get this 3.3 volt voltage regulator soldered in. I think this is a 5 volt wall wart coming into it, so it's not going to be dissipating a huge amount of heat. Cut or trim the leads off the 3 of these. 1, 2, 3. Voltage regulators in place. I continue to be grounded. IC3 is the 8-pin, probably this guy right here. Yes. So he is surface mount. He's going to go up here. And the way I'm going to approach this is I will change out to a finer tip on the pencil. I will tin up one pad where he solders in. I will work him in device or into place, and I will tack him down on that one pin, and when I'm satisfied he's square, then I will just walk around and solder the other 4 pins in basically the same way I do any other device. So let me look for the tip I want to use here. Oh, all the tips, all my soldering tips have been knocked loose and are scattered around the desk. Wonder when that happened. I know I've got there's the tip I'm after right there. So with the JVC tool, I can of course hot swap tips, which is what I'm about to do. Either one of those would work. So let's tip out, that tip in. Clean that tip up well. Tin 1 pad here, just so I've got some solder on it. Take the little device and see if I can figure out which pin is pin 1. And at the moment, I don't have a clue. See if I've got some glasses with even better magnification here. I'm sure I do. I need the flashlight. Finally, I see there's a little dot at pin 1. I finally see it. So his orientation is going to be that way. I'm sure you don't have enough magnification to really see what I'm doing here. I'm going about it pretty clumsily. I don't know what. Oh, there, I do have some tweezers. Will these work? Yeah, they will. I'm just simply gonna tack in 1 pin, check the pin alignment, and it's okay, but it's not quite as okay as I would have liked. That looks good. Let me check the pin 1 dot one more time. It's the right orientation. Some people, drag solder these, solder paste, etc. I'm just going to treat it like anything else and solder it 1 pin at a time. And just be careful not to create a solder bridge. Maybe I can get the solder to flow, and I've created a bridge. Don't know if I can clear it with just the no, there's just a little too much solder there. I'm just going to remove it all. And resolder. I do have some finer pitch solder here that would probably work a little better for this. but with a little bit of care and patience, I can get an adequate solder job. In this case, more light is better. I don't see any bridges. That looks good. There's a despiking cap C4 that goes with this guy. I'll go ahead and take care of him now. Hot swap back to my other tip. I believe I just bumped the camera, sorry. We're kind of getting down through the components. There's a dip switch. I'm sure there's an orientation that goes in. Dip switch to position. I'm not actually sure which way it should be in. Just because the switches are numbered 1 and 2, and I don't know which one should be where. There's a star. Axle. What does he call out putting the switch on? I don't see. Or maybe there is an indicator here. Looks like it goes this way. That would make sense. Pin 1 would be towards the asterisk. In this case, I'm going to hold it in place, get some solder on the tip, and just tack one pin with the solder that's on the tip. Well, I say that just to kind of hold it in place. It's square, it's flush. Solder the other 3 pins, and then I'll come back and reflow the pin I started with. That gets switch 1. There's a large electrolytic C5. C5 is a 47 microfarad, 2.5 millimeter, which is this guy right here. C5 is here. There's silkscreen for positive and negative. That looks correct. Flow one lead, then I'm going to push him up flush. We have the RTC IC. Hopefully I can get into the socket. It seems, of course, I can hold on to the little... Wow, I really can't hold on to this. Little piece of anti-static plastic wrapped in tape. The device is in. His pin 1 marking is obvious. He's in place. We've got the little teeny tiny crystal we can peel out of here. This is a little 32.768 kilohertz crystal. Sets the time base for the real-time clock. Get him to release from the tape. The two little leads are teeny tiny. Getting flush. I'm going to go ahead and actually put a bend in the leads to facilitate mounting. The leads need to be spread a little bit further apart, about 0.1 centers. And we'll see if I can get lucky and just drop him down in there, which I just did. So he just kind of dropped down in. Little piece of tape. Hold him in place while we solder. I'm not convinced I got both leads soldered. Not happy with that. Afraid of breaking him off here. There, the lead came a little further down through the hole. Okay, I'm satisfied but not thrilled with that. Of course, we've got the little standoff, so I'll go ahead and clip in at this point, maybe, if I can get them to go in. Wow, is that ever tight? There's one. Wow, those are amazingly finicky to get in there. Well, the next step is to go on to these box headers. Like I said, I'm not going to run video of me soldering all these. There's just no reason to, to do that. So when I come back, we should have the board assembled and we'll go from there. So I just reviewed the notes up on Peter's website again. I think I've got everything correct. I've got all of the female headers in place and soldered up. I'm going to just measure the output of the wall adapter, although I believe he says he's already tested it. I'll just check it myself, make sure that it's outputting 5 volts, and then I'll take a look at the output of the 3.3 volt regulator just to make sure there's 3.3 volts there. Just a couple of quick checks because I can do it. So I expect to see 5 volts DC here, and I do 5.19. Throw power on here. He's got ground labeled right here. I see 5 volts in. I see 3.3 out. Again, I see 5 volts, 5.19 in, 3.31 out. So the voltage regulator is working. His notes indicated that only one of the switches is used, and by default the switches are normally left open, and they're both open. I guess the next step here are the two modules. know, he pre-tests these modules, which is a good idea. Kit or assembled version, make sure the modules going out function. There's the Ethernet module, which mounts here. Make sure the pins are all in the holes and I'm not offset one pin forward or back, with the RJ connector pointed out. We have the heart of the system, which is the little, I believe it's an FPGA module here. And the notes on his website indicate that the box header for programming goes out. So it should go in here. I'm looking at all the pins. Nothing is a row forward or back. Just gentle pressure to get him down in. He's inserted. At this point, I believe I should see LED activity, maybe. And I do. I'm assuming the red LED is just a indicator it's on. I have no idea if the red means anything or not. I've got the compact flash card here. If I can get it out of the little bag. The jumpers are preset correctly. The OS is already installed. There's a notch for the correct orientation for this to go in. The notch was towards the resistors. Again, he is correct. He's not one pin offset to the right or left. I have the red and green LED on the CF card. The yellow is the activity. Since there should be no activity on it, that should be fine. That's a pretty good list. Let me see if I've got a CR2032 battery. I believe I've got one lost here someplace. Well, maybe I don't have a CR2032 convenient here. There they are. Okay, I did find a little storage box with batteries and battery connectors and stuff I've collected over the years. I'll just take a fresh one. I've got one fresh one left in here. If I can get it out of there. It's wedged down in there pretty well. Really didn't want to come up out of there. It's amazing the stuff you accumulate over the years. So there's a nice 3-volt 2032. It should just snap down into the battery holder like so. We've got battery backup for the RTC. I think we're ready to move on to seeing it come to life. I've got the box header for programming the FPGA out as it's supposed to be. There's the Ethernet connection. This should be hopefully ready to apply power and see what happens. So we'll move on to that step next.